This is a video that's going to work through the work-kinetic energy theorem. Now, you have already come across a different way of answering questions like this, so just view this as an alternative, but here we go. We're going to have a block. We can give it a mass of 10 kilograms. We're going to push it up a ramp. The ramp gets an angle of inclination of 37 degrees, and we're going to push it this way. We'll apply a force of, well, let's say 150 newtons, and we're going to push the block some distance and we'll go with 8 meters. I would like to find the speed at the top. So here's what we've got. First, we're going to list the forces that are acting on this thing. So forces. We have the applied force, that's an easy one. We have gravity. And we have a normal force from the ramp. So if I draw those, right, we've got our applied force, we've got gravity, and we've got the normal force from the ramp. I want to find the speed of the block at the end, so I'm going to do this using the work-kinetic energy theorem. If I have a displacement that goes up my ramp, right, my displacement is in this direction, then the very first thing I can say is that my normal force will not do any work. It's perpendicular, there's no work done. The applied force, the work done by that one is going to be the parallel force times the displacement. The force is in the direction of the displacement, so it's just going to be 150 newtons multiplied by 8 meters. And that's 1,200 joules. Now gravity. Gravity is going to be a force parallel times a distance. My force, I've got an mg. I'm going to break that into two components. Now I could either break my force into components or my displacement. I'm going to break my force this time because I've got to pick one, and that's the one I'm going with. This side, there's my angle, this side is going to be equal to mg sine theta, so my force parallel is going to be mg sine theta. I'm multiplying that by my distance, and gravity wants this thing to move down, it's moving up. There's a minus sign on here. So I can plug in my numbers. Negative 10 kilograms, 10 meters per second squared. The sine of 37 degrees is 0.6. And then the distance is 8 meters. And I can do that. 0.6 times 8 is 4.8. Times 10 is 48. Times another 10 is 480, with a minus sign is negative 480 joules. So, I have my initial kinetic energy, which was 0, I started from rest, plus my total work equals my final kinetic energy. My total work is 1,200 joules minus 480 joules, and that equals half m v final squared. I'm solving for v final. My v final is 1,200 minus 480 is 720 times 2 divided by the mass of 10 kilograms and take a square root. 720 times 2 is 1440 over 10 is 144. And then I'm going to end up with a square root. So this is meters squared per second squared, or joules per kilogram. Take the square root of that and I get 12 meters per second. And that's my final answer. I looked at the work done by each individual force, added those up, 1200 minus 480, said that plus my initial kinetic energy equals my final kinetic energy, and then I solved for my final speed. That's it.